Every comet that has ever been observed in the history of astronomy follows one basic, unbreakable rule. Point a telescope at it, and its tail will always be pointing away from the sun. Not sometimes, not usually, always, without exception, because the physics behind it is simple and well understood, tested across centuries of observation. And then, in the summer of 2025, astronomers pointed the Hubble Space Telescope at a newly discovered visitor from outside our solar system, and found something coming out of it that broke that rule in a way nobody could immediately explain. Not a tail pointing away from the sun. A jet, a narrow focused stream of material pointing directly toward it. And more than a year later, after multiple telescopes, multiple published papers, and some of the most careful observation any interstellar object has ever received, scientists still do not have a complete explanation for why it's there. Let's start with what this object actually is, because the context matters enormously. On July 1st, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, part of a global network specifically designed to scan the sky for objects that could threaten Earth, picked up a faint moving speck far out near the orbit of Jupiter. Follow-up observations quickly revealed something extraordinary. This wasn't an asteroid or a comet that belonged to our solar system. Its orbit was hyperbolic, meaning it wasn't looping around the sun the way every planet, moon, and native comet does. It was passing through, on a trajectory that had brought it here from somewhere else in the galaxy entirely, and would carry it back out into interstellar space once it left. It became only the third interstellar object ever confirmed in the history of astronomy, following Oumuamua in 2017 and Borisov in 2019, and astronomers gave it the designation 3I/Atlas. From the very beginning, this object stood out. It was moving at roughly 68 kilometers per second at its closest approach to the sun, extraordinarily fast even by interstellar standards, and observations suggested it might be significantly older than anything else ever studied up close. Potentially a genuine relic from a star system that existed long before our own sun ever formed. On July 21st, 2025, just weeks after its discovery, NASA's Hubble Space Telescope captured its first detailed image of the object, revealing a glowing, teardrop-shaped cocoon of gas and dust surrounding a solid, icy core, the same kind of coma that surrounds most active comets as sunlight begins vaporizing their surface ice. But there was something else in that Hubble image, something that took careful analysis to fully appreciate. The glowing halo of light around the object didn't just extend away from the sun the way a normal comet's tail would. It also extended noticeably toward the sun, roughly twice as far in that direction as you'd expect from ordinary scattered light. Because the viewing angle at the time was nearly aligned with the sunward direction, astronomers calculated that what they were actually looking at, foreshortened by that viewing angle, was a tightly focused jet extending outward from the object, oriented directly toward the sun, and stretched to something like 10 times longer than it was wide. In the entire recorded history of comet observation, a genuinely collimated sunward-facing jet of this kind, one that isn't simply an illusion created by viewing angle, had essentially never been documented before. To understand why that's strange, you need to understand why comet tails point away from the sun in the first place. As a comet approaches the sun, solar radiation heats its icy surface, causing gas and dust to sublimate off into space. Once that material is released, two separate forces immediately take over: the pressure of sunlight itself and the outward push of the solar wind, the stream of charged particles constantly flowing from the sun. Both of those forces push outward, away from the sun, which is why every comet tail in recorded history streams out behind it, away from our star, regardless of which direction the comet itself happens to be traveling. A jet of material pointed directly at the sun should, by that same physics, be almost immediately overwhelmed, pushed backward, and dispersed. It should not remain a narrow, focused beam, and yet that's exactly what kept being observed. Through the following months, as 3I/Atlas continued its approach toward the sun, astronomers using a ground-based instrument called the 2-meter twin telescope in Tenerife, Spain, tracked this feature more closely, gathering observations between early July and September of 2025. What they found, published as a formal letter in the peer-reviewed journal Astronomy and Astrophysics, was that this sunward jet wasn't just present, it was wobbling in a very specific periodic way as the object rotated, with its base offset by less than 8 degrees from the object's own rotational poles. In plain terms, this meant the jet appeared to be anchored to a fixed location near one end of the object's spin axis, and that spin axis itself was found to be aligned to within about 7 or 8 degrees of the direction pointing straight at the sun. That's an extremely specific, extremely unlikely geometric coincidence for an object whose orientation, as far as anyone can tell, was set randomly however many millions of years ago it formed, drifting through interstellar space long before it ever encountered our solar system. Then, on October 29th and 30th of 2025, 3I/Atlas reached its closest approach to the Sun, passing at a distance of about 1.4 astronomical units, just inside the orbit of Mars, before swinging back outward. And here is where the mystery deepened, rather than resolved. If that original sunward jet had simply been the result of one particular patch of exposed ice on the object's surface, happening to face the Sun as it approached, you might expect that feature to shift, fade, or disappear entirely once the object's orientation to the Sun changed after making its closest pass. Instead, when Hubble captured new images of the object in January of 2026, well after perihelion, the sunward-pointing jet was not only still there, it remained tightly focused, still collimated to within a similar narrow angle, now extending out to a distance of roughly 500,000 kilometers, farther than the distance between Earth and the Moon, all while still pointing almost directly back at the Sun, despite the ongoing pressure of solar radiation and solar wind that should have long since dispersed or bent it. Researchers studying the object noted that this persistence implied something specific and, frankly, strange, that the object appeared to have not one, but effectively two separate active regions positioned near opposite ends of its rotational axis, taking turns being illuminated and active depending on which side currently faced the Sun as the object's orientation shifted before and after its closest approach. Two independent pockets of exposed ice, both positioned with unusual precision near the object's poles, both becoming active only when angled towards sunlight, and both apparently well insulated enough that they stay dormant on the far side, rather than continuing to vent randomly. Is this a coincidence? Statistically, researchers who have gone through the numbers describe the odds of this kind of alignment happening by pure chance as extremely small, down in the range of a few thousandths of a percent, when you combine the object's rotational alignment with the collimation and persistence of the jet itself. That doesn't mean it's not possible. Chance alignments do happen in nature, and interstellar objects are a genuinely new category of thing for astronomers to study, with a sample size of exactly 3 confirmed examples in all of history. But it does mean the leading natural explanation, that this is simply outgassing from an exposed pocket of ice heated by the Sun, still leaves real, specific, unanswered questions about why that ice happened to be positioned exactly where it is, and why the resulting jet stays as narrow and stable as it does across a distance so vast that ordinary solar pressure should have already scattered it. It's worth being very clear about where the broader scientific community actually stands on this, because this is exactly the kind of story that tends to get overstated. At a NASA press briefing held on November 19, 2025, agency officials reviewing the full body of data collected on 3I/Atlas concluded that, taken as a whole, the object behaves consistent with a natural comet, one shaped by unusual formation conditions and an unusual ancient origin, but a comet nonetheless, not something engineered or artificial. That remains the mainstream, majority position among astronomers actively studying the object. At the same time, a small number of researchers, most vocally the Harvard astrophysicist Avi Loeb, who has spent years arguing that interstellar visitors deserve closer scrutiny for genuinely unusual behavior, have pointed to this jet, along with a longer list of other subtle anomalies in the object's size, estimates, trajectory, and composition, as reasons the case isn't fully closed yet, and have gone as far as suggesting, as one hypothesis among several, that a tightly focused sun-facing jet is at least worth considering as something other than natural outgassing. This view remains a minority position, actively disputed by most of the astronomers working on this object, and it has not been supported by any confirmed evidence beyond the same open, unexplained observations everyone agrees are genuinely there. The honest state of the science right now is not that anyone has proof of anything exotic. It's that the leading natural explanation hasn't yet been nailed down to everyone's satisfaction, and the object producing the anomaly is now fading from view on its way back out of our solar system for good. Because while all of this was unfolding, 3I/Atlas was also delivering genuinely remarkable, far less contested science. Observations using the James Webb Space Telescope, published in the journal Nature in June of 2026, found chemical ratios in the object's coma, including specific ratios involving carbon and deuterium, or heavy hydrogen, that don't match anything typically found in comets that formed within our own solar system. A separate study using the European Southern Observatory's Very Large Telescope in Chile, led by astronomer Cyril Opetom, examined the object's carbon and nitrogen chemistry and concluded that 3I/Atlas most likely formed in the outer reaches of an old, distant star system, potentially one considerably older than our own sun, making this comet, if the chemistry holds up, quite possibly one of the oldest individual objects ever directly studied by human instruments. And in May of 2026, a separate research team led by the University of Michigan found that water detected on the object carried an unusually high concentration of deuterium, far higher than typical solar system comets, a signature that offers real, hard evidence about the extremely cold conditions the object likely formed in, over 4 billion years ago, around a star system we will never be able to visit or identify. So here is where this genuinely stands, honestly, as of today. Scientists have a real, confirmed, repeatedly observed jet of material coming out of an interstellar visitor, pointed directly at the sun in defiance of the basic physics that governs every other comet ever recorded, persisting for months, surviving perihelion, and remaining narrowly focused across distances larger than the gap between Earth and the Moon. The leading explanation is natural. An unusually well-positioned pocket of ancient ice, exposed at just the right moment, venting in just the right direction. But the fact that this remains the leading explanation rather than a settled one tells you something important about where planetary science actually is right now. We are still working out the basic rules for how objects that formed around other stars entirely are supposed to behave once they arrive here, because until 2017 we had never confirmed a single one, and we now have exactly 3 data points to build a general theory from. 3I/Atlas made its closest approach to Jupiter in March of 2026 and is now heading back out of our solar system for good, fading from view as ground-based telescopes lose the ability to track it. Once it's gone, it's gone. There's no way to send a mission to catch up with it, no way to get closer instruments to it than the ones already trained on it from Earth, and no second chance to resolve the open questions this specific object leaves behind. Whatever finally explains that sunward jet, whether it turns out to be a beautifully specific but entirely natural quirk of ancient cometary ice, or something that forces a genuine revision of how these objects are understood, the answer will likely have to come from studying the data we already have, because the object itself will simply keep moving, carrying its unanswered question with it back out into the dark between the stars where it came from. If stories like this, the ones where real telescopes keep finding real anomalies that don't yet have a tidy answer, are what you come here for, stay close, because there is more still out there, waiting to be explained.